Mhm. Mhm. Hello everyone, welcome to the class, and just give me one moment. Let me just check if I am live streaming. Okay, all right, and welcome to the first class. Today is my first class for class 11, and in this class we would basically begin with your unit 1 topic, which is basically physical world and measurement. We will start your first lesson from the unit of measurements. All right. And before I go ahead, my name is Mohana. I'm a physics educator here at Unacademy. So basically, your ISC class 11 and 12 physics I would be taking on the platform. And I have a master's degrees in physics, and I hope I can help you with your class 11 preparation. And I've shared my Telegram link over here. So this is my channel, my Telegram channel. So before going live for any classes, like I'll be sharing those Telegram links in this group, right? I'll be sharing the links in this group on any updates that are there would be shared in this group. Similar to that, we have a channel for the common ICSE and ISC both channel is there, and the Telegram channel is over here. Can I follow me over here? All right. And so just like how this is a free class for you that we're taking on the YouTube channel, similar to that, on the Unacademy platform, in the Unacademy platform, we basically have free classes that we call them as special classes. Now, these special classes are absolutely free. You can learn from any of your favorite educators, okay? And we have an interesting feature in the Unacademy platform that is basically your polls. So what we do is we basically, you will learn a topic, right? And as you learn, let's say you learn 2 or 3 concepts today. So there will be some question based on those concepts, and you can answer those pool type questions, just like the one you can see in my chat box right now, right? And you can answer those to learn, to understand whether you've understood the concept or not, okay? And these special classes again on the platform also would be a live class like this one. So any doubts you have, you can ask the educator through chat box. And the link for the upcoming special classes, so these classes are absolutely free. So in the month of April, we tried covering the concepts of the first unit 1 and unit 2. So this month, I am basically in the special classes, basically on the platform, I would be covering topics from your third unit dynamics. Okay, so the next class is basically tomorrow. We have one class at 4 p.m. And again, the class after that, the special class on the website would be on 30th May, that is at 4 p.m. So this would be the topic would be introduction to laws of motions, and the next class that will be to introduction to impulse. So this is basically your unit 3. Mm-hmm. So you can take the free class here, and when you want, you can actually take your classes in the app. Right, you can basically take the special classes in the live in the educator platform, in the Unacademy platform as well. And so other than the special classes, we also have plus subscriptions. So if you're taking any plus subscriptions with Unacademy, okay, you can basically all of these classes are online classes, so you can learn from your comfort, from the comfort of your home, okay, and you'll get unlimited access to all courses. And all the educators at Unacademy are basically really good, so you can learn from the top educators. And we have one more interesting feature, that is every 4th class. So whenever we start a particular course, the 4th class, the 4th session of that course will be a doubt class. Okay, now in the doubt class, let's say in the first 3 classes, whatever topics we have learned in the doubt class, any doubts you have regarding that, you can ask. Okay, and in the special classes, we will be covering your complete syllabus as well. And again, you will have special mentorship and guidance as well, and there would be a lot of practice tests. And also, one more interesting features with these plus classes is that you will have these live test series. So every week, right, or every other week, you will have some live test series. So this is basically why we have included this as any concept. If you're learning, if you're taking a test on it, right, you will be able to assess whether you've understood the concept or not. Right after the test series, there is also analysis session for the test series. So you can, if you got any questions wrong, you can actually learn in there what would be the right method, and any doubts you have also you can see. So there would be many upcoming batches and courses, so do check out. And now coming to the pricing of the courses, so here as you increase the duration of the course, the price per month reduces, right? So if in case you're taking for your class 11 and class 12, let's say for 2 years course, then you're getting the course for about 1198 per month, okay? And you can actually use my code MTIS10 to avail a 10% discount. Okay, so any course that you're taking, if you're using this code MTIS10, you can avail a 10% discount. At the same time, any special classes you want to join to, right? You can again use the same code MTIS10 on the platform, and the special classes, the classes that I've taken till now would basically be available for you on the platform. And in today's class, we are basically starting with the topic measurements, right? So physics is basically a branch that that basically deals with the nature and the natural phenomena around it, right? So if you want to properly describe any natural phenomena that's happening around you, right, you need to be able to measure it, right? You measurement based on it, right? So you should be able to measure it accurately as well, right? So physics is based on measurement and comparison. Okay, so through physics we get an accurate knowledge of nature and the natural phenomenon. Okay, you would basically learn about why the sky is blue, or that's a natural phenomenon, right? Or why do you see rainbow, right? All of these are basically your natural phenomena. Now whenever you want to express any of these natural phenomena, you express them in terms of relationships among the quantities involved between them, right? Now let's say the speed of a particular car is around 5 meters per second. Now how do we express speed? As in, we would basically give speed or velocity. That is basically we give it by distance traveled by time, right? Velocity means you say this is the distance traveled by time, right? Speed again will be like distance traveled by time. So you give a particular quantity, right, in terms of relationship with another quantity, right? And also the accuracy of these relationships depends upon the measurement that we make. Okay? So when you're measuring distance or time, only if these measurements are very much accurate, your velocity or the speed that you're measuring, right, that particular quantity of whatever you're measuring, those measurement is basically dependent on how you measure. In this case, your length, the length measurement, that in case when you're saying a distance, you're basically talking about the length, right? So the length that you're measuring has to be extremely accurate. So again, how does this accuracy of these measurements, they basically depend upon your measuring instrument and techniques. Okay, and so basically physics is basically dealing with the nature and its natural phenomena, and in terms, right, so it is basically based on if you want to study any natural phenomenon, you should be measuring that particular phenomenon, right? You should be getting an accurate measurement of that particular phenomenon that you want to study. Okay, so you can say physics is basically a science of measurement. So you can say physics is a science of measurement. Okay, so Lord Kelvin, he gave a very amazing sense. He quoted that when you can measure, okay, when you can measure what you're speaking about, and if you're able to express them in numbers, then it means you know something about it. But when you cannot express them in numbers, no, then your knowledge of it is of a meager, and it becomes an unsatisfactory kind. So what basically he's trying to saying is, let's say you are going from your school to your home, okay, and say the distance that you're covering, right, that is basically 10. Let's say you're covering a 5 kilometer distance. So if you know, right, if you can actually say, right, from my home to the school, the distance I'm walking is 5 kilometers, then you know something about that particular quantity. right? And if when you can give it in terms of numbers, then you actually can relate it with some other quantity as well. Now that you know the distance from your home to school, now you can calculate what will be the distance to from your home to particularly probably around the shop nearby, right? So whenever you can express any quantities in number, then it means you have we know something about those quantities. Okay, so right, so yeah, so what are these basic quantities that we are talking about? Okay, all these quantities that can be directly measured, or that can be measured directly or indirectly in terms of laws of physics, can be expressed through two ways. Okay, a quantity is not quantity linked to any physical phenomenon and which is subjected to measurement may be treated as your physical quantity. And all of these, for example, length, right? Your length, mass, time, right? So just give me 1 minute. Right. Okay, so basically the length, right, mass, time, force, speed, all of these physical quantities, right, physical phenomena, the quantities linked to any physical phenomena, right, and which is subject to measurement can be treated as a physical quantities. And so physical quantities are something that can be measured. For example, how long you're taking this class, that can be measured, right? What is the duration in which you're taking the class, that can be measured. Similarly, you can also check, like, what is the how many hours you've attended a physics class, right? These basically can be measured. And if you want to find out what is the momentum, or if you want to find out what is the force, like if you're throwing an object, what is the force in which you're throwing an object, what is the force you're applying to that object, these can be measured. So these quantities which you can measure, these are basically called as physical quantities. And quantities that you cannot measure, for example, how much I do not like attending class, right? I cannot measure that, right? How much you find the subject to be difficult, that is something you cannot measure. How bored you are to attend the class, that is not something you can measure, right? So these quantities which you cannot measure, or you cannot express them, right? These are not measurable quantities, right? These are not put into under physical quantities, but only quantities which you can measure comes under physical quantity. Okay, and these physical quantities are of two types. One is a fundamental quantity, another one is a derived quantity. Now these physical quantities which can be treated as independent of other quantities, okay, and are usually defined by in terms of other physical quantities, right? These which are not usually defined by in terms of other physical quantities, they are called as fundamental quantities. But physical quantities whose defining operations are based on other physical quantities, right? For example, the fundamental quantities, these are like very independent. For mass is a fundamental quantity. Okay, then this how much length is a fundamental quantity, right? Time is a fundamental quantity. Now any quantities that you can derive from these fundamental quantities is called as a derived quantity. If you know, right, if you want to find out what is your velocity, right, or what is the speed in which a car is going, okay, then you should know how much distance it covered with time. So distance we measure in terms of length, right? And then again, distance is a fundamental quantity, length is a fundamental quantity. Like if you know these two, right, then you can actually find out, then from here we can derive a velocity, which is basically your fundamental derived quantity. Okay, so fundamental quantities are basically quantities that are treated independent of other quantities, okay, and derived quantities are basically quantities which are derived from these fundamental quantities. All right, and the measurement, okay, so the measurement of any, if you want to measure any physical quantity, right, now the measurement of any physical quantity, this is basically a process of comparing this quantity with a standard amount of a physical quantity of the same kind, okay, that's called its unit. Okay, for example, if you take Abhishek Kumar Verma, I'm sorry, I am not my Hindi is not really good, so I cannot really speak in Hindi, but I'll go very slow in English. Is that okay? So if you do not understand, just tell me. Whatever I did not understand, just tell me I did not understand. I'll repeat the same. Would that help? Okay, all right. Right. So now the very as simply as you can say, this fundamental this measurements, right? The unit. So basically, if you take anything, right, any quantity, let's say if you want to say the duration of this particular class is 60 minutes. Now 60 is the numerical value that is associated with it, right? It's numerical value that is associated with it. Minutes is basically the unit in which it is measured. Okay. Now the 60 minutes you can actually write in terms of seconds, right? Or you can write the 60 minutes in terms of hours. 60 minutes is 1 hour. So the measurement of any physical quantity is a process of comparing this quantity, right? Here what are we comparing? We are comparing 60 minutes with 1 hour with the standard amount of its physical quantity of the same kind called its units. Alright, so in a basic, so the standard amount of any physical quantity chosen to measure the physical quantity of the same kind is called as a physical unit. Okay, in this kind, time is given as seconds, right? So this is basically a physical unit. And this physical unit comes under fundamental unit as well, right? Time comes under fundamental unit. Now, so if you basically, you can actually give this in a very generalized form. So you can say that okay, now if you take the length, if you take a unit length, let's take the unit of length as, I just gave the example of time. Now the unit of length as centimeter, okay, or you can take the unit as length as millimeter, okay. Then if you take a particular length of the rod, you can say let's say the length of the rod, let's take I'm going to measure the length of a rod, okay. Now the length of the rod, let's say it is basically 200 centimeters. Now 200 centimeters in terms of millimeters, how would you write, right? In terms of millimeters, if you're writing, it will be 2000 millimeters. Okay, so it is very clear that the small unit of a physical quantity. So if you look at a smaller unit, right, here the smaller unit of a physical quantity, right, is basically has a larger numerical value. Here millimeter is a small quantity, centimeter is a small quantity, is a much bigger quantity, right? So when you look at a smaller unit, they are if you look at the numerical value, or we call this as the magnitude, right? So the numerical value is basically larger. Okay. Now if you write 60 minutes, this is in terms of time, right? 60 minutes. If I want to give this 60 minutes in terms of seconds, right? In 60 minutes there are 600 seconds, right? 600 seconds. Now this is a smaller unit when compared to minutes. The seconds is a smaller unit, but as the units become smaller, the numerical value associated with it becomes larger. Abhishek, clear till now? Can I go in the speed? Okay. All right. So if you take any two physical quantities, all right, let's say N1, okay, and N2 are the numerical values associated. Okay, these are the two numerical values associated with two physical quantities, and let's say the units associated with them. Okay, let's say these two have very different units, right? So let's say the unit of this one is U1 and the unit of this one is U2. Okay, these are the units associated with it. Now N1 U1 will be basically equal to N2 U2. Very simple, nothing but just as we did earlier, 200 centimeters of a rod in terms of millimeters it will basically be equal to 2000 millimeters. Daksha, that is absolutely right. So basically, whenever you want to express any physical quantities, right, the way you express it is extreme. What you said is very correct. You just write, I'm just going to write whatever, you'll just write numerical unit, right? You'll write the numerical value and the unit next to it. So this is your numerical value and next to that is a unit. And that's how you express the any physical quantities. And these physical quantities, using units, you can relate them, you can compare them as well. Okay. Now, all of these physical quantities, right, are basically these particular measurements that you're seeing for in all of these units, right? There are three different system of units. One is your CGS, right? So again, coming back to this question, so if you take the length, right, the length of the rod, we said let's take it as 20 meters as the length of the rod. So any physical fundamental quantities or derived quantities that you're seeing, you will see a numerical value, right? And you will see a fundamental unit associated to that value. Okay. Now, there are different types of units. There are different types of system of units, right? We have the CGS system of units, and then you have the MKS system of units, right? And you also have the FPS system of units, and also the and from the MKS system of units, from there we have the SI system of units. Now tomorrow's class, in depth about all of these units I will cover. Okay, but for today's class, let's just learn what are the fundamental quantities. Okay, and basically we will focus on the one particular fundamental quantities, that is length. Okay, so whenever you're talking about a CGS system of unit, this CGS stands for centimeter, and this stands for grams, and this stands for seconds. Okay, FPS is basically followed by British. This stands for foot, right? And P stands for pound, and again S is just for seconds. All right. Now MKS system of unit is basically your meters, okay, and kilogram, seconds. Okay, the SI system of units, this is the internationally accepted unit. So it this stands for this basically means the SI system. This is a French word, which in terms of English, when you're giving, yes, Daksha, right? The SI system of unit and MKS system, they both follow the metric system of units. I'll cover more about all of these units in the upcoming tomorrow's class. So today's class, I will focus on the SI system of units, right? These are basically called, this abbreviates to International System of Units. Okay, so this SI system of units is basically based on seven fundamental quantities. Okay, they are basically, the SI system of units basically are based on the 7 fundamental quantities. Anybody know what are the 7 fundamental quantities? Those are the basic quantities using which you can derive the derive all other quantities. So in the SI, the basic units, so SI units, you have the basic units, right? Your basic units are basically length, all right, and then you have the basic unit as mass. Time is again another basic unit. Okay, then comes your electric current, is again a basic unit. Okay, Then thermodynamical temperature. Thermodynamical temperature. This is again one more basic unit. Okay, and amount of substance. This you'll see more in chemistry. Amount of substance. This is another fundamental unit. And after that comes your luminosity intensity. Luminous intensity. Luminous intensity in the most basic form. Luminous intensity just talks about the brightness associated with an object. Okay. Alright. So today's class, let's try and focus more on this particular fundamental quantity, length. Alright. And in tomorrow's class, I will go into today's class for length. I will cover all of it. The next class, coming classes, we would focus more on mass, and then we would go into time and each of those fundamental quantities which are mostly using. Let's learn about them more. Okay. So now the length in the SI system of unit, the length is basically given as meter. Okay, and the symbol for that we give it as M. Okay, the reason why we are using SI system of unit is that one thing is it is a very rational system of unit, right? It's also very coherent, and in electricity, right, the SI system are the same as the practical units as well. Okay, and with in the SI system, with respect to electricity, right, if you're taking a current, potential, resistance, inductance, all of them are given as terms of like amperes, volt, ohms and Henry. Okay, so now to understand length is given by meter, right? So whenever you define any particular physical quantity, right, the base physical quantity that you're taking, that you have to make sure that the basic units when you're basically deriving that, but coming to that, you know, when you're basically quantifying, measuring that particular unit, you have to make sure like temperature, pressure or any other phenomenon is not affected by it. All right, that's when you can get an accurate answer. So the 7 fundamental units, right, are in that the first one that we are looking at is basically the length. In the SI unit we give it as in terms of meters. Okay, this 1 meter, if you want to define 1 meter, this 1 meter is defined. Okay, don't have to worry much about it. Try to understand as much as you can for this. Okay, so basically your right. So your 1 meter is basically given as, so 1 meter is defined as the distance containing 1000. Okay, this is a very huge number. So that is around 1,650,763.73. I'm sorry. Right, 0.73. Okay, wavelength. All right, that's the wavelength. Okay, of the orange red light emitted by pure krypton. '86. Okay. More recently, the 1 meter was defined as the 1 meter. More recently, 1 meter was basically defined as, earlier this was the definition. Recently, 1 meter is basically defined as this has been defined as length of the path traveled by light in vacuum in 1 by 299,792,458 parts of a second. That is a very accurate measurement for 1 meter. Now, why do we need such high accuracy of when you're defining a length, any unit when you're defining? Why are we so persistent about defining it to very high accuracy? Very simple reason. The global position, the GPS that we are actually using, right, will not work properly if you do not define the time, the unit of time properly. GPS would not work, right? Similar to that, every unit that we are using, everything that we are dependent on has to be measured, right? The basic units always has to be given to a very high degree of accuracy. Okay, so this is the basic. As we are advancing now, this is the latest definition that we have given for 1 meter. Okay, but the multiples of meters that we are using are, this is something we would have seen, right? Now, if you basically see 1 kilometer, right? 1 kilometer is basically, we give it as km. 1 kilometer in terms of meter, if we give, it's 10 to the power of 3 meters, right? And 1 centimeter is 10 to the power of minus 2 meters. Okay, and 1 millimeter, quickly you should be knowing, or you would be knowing all of these values, but anyway, as we'll just quickly look into this. Okay, and 1 more meter, 1 micrometer, right? 1 micrometer, this is important as you go ahead, right? As you're going towards the smallest units, right? 1 micrometer, micro is in the range of 10 to the power of minus 6 meters, right? 1 nanometers. ISC board nowadays, wavelengths, when you're asking, right, they ask you to express not in terms of angstrom but in terms of nanometers. So nanometers is given as 10 to the power of minus 9 meters. 1 angstrom is very simple. Angstrom is nothing but 10 to the power of minus 10 meters. Okay, here nanometers 10 to the power of minus 9 meters. Okay, so then 1 femtometer, okay, or 1 fermimeter or 1 femtometer, this is very important, 10 to the power of minus 15 meters. Now this femtometer, 10 to the power of minus 15, right, this is basically your size of your nucleus inside an atom. Okay, so if you want to measure very small units, then we use the unit called as barn, and 1 barn is basically equal to 10 to the power of minus 28 meters square. Okay, now we went down, right, we went down the line and we basically saw what the smallest units, right, that is what we were actually we were just seeing how small a unit can get. So we went up to the size of the nucleus in an atom, that is about 1 fermimeter or 1 femtometer. Okay, now what if we go on the other round, right? What if we keep going outside? What if we go macroscopic level, right? Now when you're measuring such high distance of macroscopic levels, right, you can't keep expressing everything in terms of meters, so we use other units of length. Okay, the first unit that you are going to be learning is basically your 1 astronomical unit. Okay, your astronomical unit. Now your astronomical unit is nothing but we give it as AU. Astronomical unit, we give it as AU. This is the average distance between the sun. If you have the sun and this is your earth, what is the distance between the sun and the earth? That is 1 astronomical unit. Okay, so 1 astronomical unit, 1 AU is the distance from right, I'm really sorry how to pronounce it. The course of class 11 would be launched in the month of June first week. I think the first course starts by around June 9th. Does that answer? Towards the end of the class, I'll give you the exact date of the class 11 course for each of the subject. Would that help? The distance from So 1 AU is basically the distance from, you're welcome. Okay, 1 AU is the distance from your is basically the average distance. This is basically your average distance of sun from earth. Average distance of sun, okay, from earth. All right, now 1 astronomical unit in terms of meters, if you want to give, it is around 1.496 into 10 to the power of 11 meters. You can give it as 1.5 into 10 to the power of 11 meters. Okay, now that's 1 unit as we go. So how do we give the distance from earth to sun? We give it in terms of astronomical unit. Okay, now right, so similar to that, now if in case if you're using, okay, now right, now 1 light year, right, one more unit that we give it is in terms of light years. So 1 light year is basically the distance traveled by light in vacuum, okay, in 1 year. Okay, so we actually know that light travels at the speed of 3 into 10 to the power of 8 meters per second, right, in vacuum. So if you want to find out what is 1 light year, we give it as Ly. So that would be basically what we know, this travels at the speed of 3 into 10 to the power of 8 meters per second, right? That's the speed of light. Okay, so now 1 light year will be what? Speed of light times 1 year, right? This is the speed of light times the 1 year. So 1 year, you can actually write 1 year as 365 days, right? And each day has 24 hours into 1 hour. 1 day has so 1 hour has 60 minutes and 1 minute has 60 seconds. Okay, now we have expressed it in terms of seconds, right? So this is meter per second and this is second. So seconds will basically get cancelled. Now if you multiply this, you will get 1 light year as 9.46 into 10 to the power of 15 meters. Okay, any doubts still here? All right, now other than this, we also define the unit of 1 parsec, right? 1 parsec or parallactic second, right? This is basically the distance, right? This is basically the distance, okay, at which average average radius of Earth's orbits around sun. Okay, this Earth's orbit around sun, this is basically, we are basically looking at the distance at which an average radius of Earth's orbit around sun. This radius of Earth's orbit around sun, this we basically give it as an arc length 1 AU, okay, of an arc length of 1 astronomical unit, right? Would suspend an angle. This basically gives you, would suspend an angle of 1 inch or 1 second of an arc. Okay, So this 1 parsec is basically equal to 1 astronomical unit by 1 second. So this is basically arc second. Okay, and so if you want 1 astronomical unit, this is basically given as 1.496 into 10 to the power of 11 meters, right? And 1 arc second is nothing but 1 divided by 3600 degrees, right, into pi divided by 180, which in terms of seconds, arc second and arc minutes that you're seeing in terms of radian, if you're converting, will be pi divided by 180 degrees. This will basically equal to 4.85 into 10 to the power of minus 6 radian. Okay, so if you take 1 parsec, this is basically equal to 1.496 into 10 to the power of 11 meters divided by 4.85 into 10 to the power of minus 6 radian, right? So this in terms of meter will be 3.084 into 10 to the power of 16 meters, alright, and 1 parsec is basically 3.26 light years. Okay, in terms of meters, this value, so this is in terms of meters, if you're giving 1 parsec is 1.3 into 10 to the power of 16 meters, right? Same in terms of if you're giving it the same thing if you're giving in terms of light years, it will be 3.26 light years. Okay, so there are basically 7, to recap, there are basically 7 fundamental units and 2 derived units, and 2 supplementary units are also there. The types of the different system of units, I've given a quick recap, but anyway, we would do that again in tomorrow's class. And in this class, we saw the units, basically we focused on the measurement unit of length, right? We gave the unit of length as we go down, right? What was the value, right? As you go towards the size of a nucleus, what was the value? And also we started seeing the unit in terms of astronomical scale, like what is 1 AU, or what is 1 light years, okay, and what is 1 parsec. So now the derived units that we are seeing, right? See, there are around right, okay. See, the derived units are basically units that you can get from your fundamental units, okay? Just like how you have your derived quantities that you can get from your fundamental quantities, the derived units, you can get them from your fundamental units, right? So all the 7 fundamental quantities has 7 fundamental units associated to them. Similarly, so would be your derived units, right? So derived units are very simple, right? For example, volume. So volume is basically given by length into breadth into height, right? So in terms of units, right, your volume is length, breadth into height. In terms of units, if you're saying unit of length is basically again meters, breadth is also meters, height is also meters, right? So you basically get the volume, if you want to express in units, that is basically meter cube, right? Similarly, what would be density? What would be the unit of density? Unit of density, the density is basically given as mass by volume. Okay, now mass, so now we know mass is a fundamental quantity, right? In SI system of unit, for mass we give it as kilograms. Just now we saw we derived the unit of volume. Volume was meter cube, so mass per meter cube, which we basically give it as kg m inverse 3. What would be velocity? So you can get velocity, the unit of velocity from if you know the unit of distance and time, right? Velocity is basically your displacement by time. So if you know what is the unit of displacement, right? In terms of SI units, we give it as meter per second. So MSI1, right? That would be your unit. What would become to acceleration? So if you want to derive the unit of acceleration, obviously we know acceleration is basically given by change in velocity by time. So what will be your velocity, the change in velocity? The velocity is given by, right, meter per second by time. So when you bring it on top, the acceleration unit will be meter per second square. Okay, so from here we can see, right, meter per seconds I'm able to see. I'm sorry, I'm not very sure how to pronounce your name. So good job, that's the unit for velocity. And next is basically again the unit for force. Right, the unit for force, right? Force is given as what? Mass into acceleration. Who can give the unit for force? Who can actually give the unit for force? Right, right, Ozair, or I hope your name is pronounced as Ozair. Right, yeah, correct. Unit of force is basically Newton. So the force, right, can we basically give the unit of force as Newton? Can you tell me what would be 1 Newton? 1 Newton, right? 1 Newton will be equal to dynes and Celsius units. That is okay, that is right. So in terms of SI units, 1 Newton is basically given as, what is your mass? Mass is meter per second square, right? So sorry, mass is basically kilogram. Acceleration is what? Meter per second square, correct? So from here we can say acceleration is kg, right? M S inverse 2. So this basically 1 Newton is equal to 1 kilogram mass per second square. Okay, now right, okay, from here right, so again, what would be pressure? What would be the unit of pressure? Pressure is given as what? Pressure is basically force per area is basically pressure, right? So that is right, correct. Your units Pascal and Newton per meter square both are right. So pressure is basically force per unit area, right? So the unit of pressure if you want to give, it would basically be, for force it is kilogram meter per second square by area, right? Area we give in terms of meter square, correct? So when this so from here we can say this is nothing but kilogram meter per second square. This is nothing but Newton per meter square. So we can give this as Nm inverse 2. So 1 Pascal, that is PA, right? The short form we write as 1 Pascal is equal to Newton per meter square. Is equal to 1 Newton per meter square. Okay, what about work? How would you define work? Work is nothing but, let's say you're pushing any object to a certain distance. Okay, so basically if you want to do that, if you want to move an object, let's say you want to if I want to move my book, right, move my book that's on the table from here to this, right, I apply a particular force, that is I push the book aside, right? So when I apply a force, there's a particular the book is getting displaced, right? It's covering certain distance, so it's covering particular distance. Akshay, Ozair, both of you, the answer joule is correct, right? That answer is right. Okay, so here work is nothing but you're applying a particular force and the particular object is getting displaced, right? So work is nothing but force times displacement. Okay, and here force, we already know what the unit of force is, right? The unit of force is basically Newton meter, right? Here this is Newton, unit of force is Newton. Displacement, how much it is moving, so that's more the length, it is the distance it is moving, right? That is actually given in terms of meters. So if I'm moving my book from this, if I'm applying a force and I'm basically pushing my notebook down, right? How much am I pushing it to? Let's say it's moved by 5 meters. So that is given actually in terms of the unit of length, right? That's 5 meter. Ozar, you're in 10 CBSE. Oh, right, nice. Okay. I hope you're completing your syllabus. You're completing your year this year, right? You're going to take your class 11. Are you starting your academic year, class 11 academic year this year, from this June onwards? So Newton per Newton meter, and over here this the unit of work is okay. You are in your 10th standard syllabus. You are doing your 10th standard now. Okay, great. So this work is basically given again by joule, right? And 1 joule, if I want to give short form, is basically joule, right? 1 joule is basically 1 joule is basically 1 Newton meter. 1 Newton meter, if I want to express in terms of kilogram meter in seconds, then that will be 1 kilogram, right? Force is given as meters, second inverse to, into another meter is there over here. So this becomes 1 kilogram meter square per second square. Alright, so the unit of work is basically joules. We give it in terms of joules, and 1 joule is 1 Newton meter or 1 kilogram meter square. Okay, and second square. Let's do one more. What about power? What is the unit of power? Power is given as watt, that is right. So how do we define power? Power is actually work done per time, work by time. Okay, and obviously we know the right, work done, energy consumed per time, right? They can say it as that as well. So power is basically work by time, and over here we know work is nothing but 1 joule. Time is in terms of seconds, so you can write this as 1 joules, right, per second. Now again, the unit of power is also given as watt. So 1 watt is basically equal to 1 joule per second. Alright, so again there are certain guidelines whenever you're writing this SI system, right? The symbols that when you're writing, there are some guidelines. First one is if you look at any symbol, sometimes we use small Roman letters. If you're talking about, in case you're talking about your electromotive force, we sometimes give it as E or epsilon. Angle, theta, right? So we usually use small Roman numericals, alphabets, right? Roman letters are used usually in case of units, and always symbols are not followed by a full stop. Okay, when you're writing a full symbol, let's say I'm writing the pressure as PA, it's not followed by a full stop. Okay, and whenever you write full name, right? Whenever you write full name, so for example, if I'm writing the unit of joules, right? If I'm writing joule is full, the capital letter, because it is named after a scientist, right? The capital, usually when we name any when you write after any person's name, what do? We give it in the capitals, right? But here in terms, when you're taking them as units, you always use the small letter, right? Joules, when you're writing, make sure it's written in small letters. But if you're just using only the capitalized word, right? Then you just use that capital G. So Newton, when you're writing what is a force, let's say you are applying, let's say you're throwing a ball with a force of 5 newtons, okay? So if you're writing that 5 newtons, you can either write that as, okay, so you can either write that Newton as 5 Newton, or you have to write as 5 Newton, capital N. You can either use small letters if you're writing the full name, write it in small letters, otherwise write the capital letters. Okay, initials when you're using, that is Newton, if I'm using the initials, then that's used in capital, just the letter. Plural forms are not allowed. You cannot write Newtons, right? You cannot write, if in case you're writing 5 Newtons, this is wrong. Plural forms are not allowed, only singular forms are allowed. Okay, so these are some things you need to keep in mind. And the next is one more quantity you need to know is the order of magnitude. Okay, should be able to express any quantities, right, in terms of the powers of 10. Okay, so for that we've already seen some of the values. Let's just cross check. Let's just cross check some more values alone, right? I hope all of you know these values. Can anyone tell me what is 10 to the power of 3? Right, what the powers of 10. So in the powers of 10, 10 to the power of 3 is basically kilo, right? Kilogram, or kilometer. In terms of length, we say kilometer. In terms of weight, is measuring something, you say kilograms, right? So 10 power 3 is kilo, and we use the symbol K, right? So similarly, let's say, yes, Akshay, that is around 1000. Yes, Oshmar, okay. Right, from Oshma's question, what is mega? Mega is 10 power what? 10 power what gives you a mega? Akshay is saying 10 kilograms is equal to 1000 grams. That is right. So whenever you're writing 1 kilogram is equal to 1000 grams, here this 1000 is basically kilo. The value of kilo is 10 to the power of 3. Correct, Osmar. Mega is 10 power 6. That is mega. Do you know what is the symbol we are using? For kilo we use K. What about mega? What is the symbol we'll be using in case of mega? For mega we use the capital M. For mega the symbol we are using is capital M. And correct, Osma, 10 to the power of 9 is giga, and the symbol we used is G. Let's say, what is 10 to the power of minus 3? What is the name of the prefix 10 to the power of minus 3? Actually, 10 to the power of 6 being mega is right. 10 to the power of minus 3. What is the name? What is the prefix? Name of the prefix. Uh, 10 to the power of minus 3, the milli, that is right. 10 to the power of minus 3 is milli. And the prefix we use is M. Let's see one more. What about atto? Do you know what value? 10 to the power of what gives you an atto? We have seen femto, we have seen nano, we have seen micro. So atto gives you what? That's right. 10 to the power of Osma, that is right. 10 to the power of 18 gives you atto. That is given by A. Okay. So today's class, being the first class, we covered very simple topic, right? We just saw what are the 7 quantities, right? And we haven't even looked into the fundamental quantities. We just took length as one unit of measurement, and we basically saw as you go down, what are the prefixes, right? Powers of 10. If you're writing in terms of order of magnitude, what will be the order, this prefix that we're talking about, right? This powers of 10 we have seen, as well as we just saw how to express certain quantities, right, in 1 astronomical units, or in terms of what is 1 astronomical unit and 1 light year. You may not have understood parsec. That's all right. We will continue that in the coming classes. Okay. So for the earlier inquiry about the classes, that is going to say, right? So the class for upcoming class for 11th is class 11th. It is basically starting from 8th June onwards. Okay, so the mode of the sub syllabus will again be the classes will be taken in English, and for each of the subjects, right? Physics I would be taking, so we would be meeting every Monday, Thursday, Saturday regularly between 5:15 to 6:15 p.m. Math classes for the same course that you're taking, math classes will be taken by Jyoti ma'am, and chemistry classes will be taken by Manisha ma'am, and Lakshay sir will be taking your biology classes. The timings of each of the classes are also given here. Okay, now again, and also you can check out tomorrow. So these are the class starting dates. It's only starting from 8th of June onwards. Your classes for your batch is the first batch is basically starting only from 8th of June, and your focus will be your midterm coverage. So we will start from your unit 1 onwards. We would start on your term 1, volume 1, unit 1, that is this topic, measurement onwards. Okay, and this is for class 12, and anyways you're joining for class 11. And also one more feature that we have in the Unacademy app is the community feature. So this is the link to my community. So if you're basically using the community, right, the educators, all the educators would be sharing any updates that are there regarding the courses in the community, and you can get the session notes or practice material, whatever you want, through the community. And also you can share your feedback directly via the educators, via the pools. So if you're joining my community, right, for class 11, they will actually, if you go in, there will be one pool question. Okay, so you can actually check that out as well. Now Bucks Bounty is one more cool feature that the Unacademy team has come up with. So in case if you're noticing any inappropriate content in any of the educators' video, you can actually report it, and if you report that inappropriate content, then obviously you would be getting some prize for it. Alright, and with that, I'm coming towards the end of the session, and thank you so much for taking the course. So press on the bell icon, subscribe to the channel, and you can like and share this video. Tomorrow the class timing will be around 2 p.m. Okay, and I would be sharing the class timing before going live. I would be sharing the class link in the Telegram group as well. Okay, right. If you have any further questions, I can end today's class. Tomorrow's class we will look into all of the units, right, all the 3 system of units, and we will cover each of those in the coming classes. Basically how we learnt about length of about each of the units, each of the physical fundamental units, right, the basic units, we will learn about them in detail. Thank you, Akshay. Alright guys, thank you for taking the class. See you tomorrow.